So guys, as you can see, these are the LEDs here and this is the keypad. Now I will press the button 1, one LED will turn on. See, I press this button 1, see. Now I press the button 2, the other LED will turn on, see. Now button 3 will turn both the LEDs off like this. So button 3 is like a reset button here. I press the button 2, the second LED is on. I press the 3, it's now off. I press the button 1, the first LED is on. I press the button 3, now it's off. I press the button 1, 2, both the LEDs are on. I press the button 3, both are off. Now I press the button 2, then 1. See, button 2 is for this one LED and button 1 is for this LED and button 2 is for this LED. I press the button 1, see, it turns on, 3 turns on. So button 2 will always turn on this LED while button 1 will always turn on this LED, and button 3 is a reset button like this. See, button 2, button 1 and then reset. So only 2, reset means a reset that it will turn off the LED whichever is on. So it turns off like this. See, both are on. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a PIC16F877A microcontroller with a 4x4 capacitive type keypad. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is the keypad I'm talking about. It's a capacitive type 4x4 keypad. As you can see that there is a male header. It has like 12 pins starting from left to right. Let me label them for you. Before that, this system has, or this module has two modes. One is the 8-button mode, which is by default. You can see that these two pins, on this you will see these points. If these two pins are not shorted, it means it is in the 8-pin mode. And in the 8-pin mode, these 8 output pins will work directly. So you can directly take the output out from here. They will give logic high. So you can program it like 1. Whenever the button is pressed, a 1 will be set from the respective pin. So out 1 correspond to 1, out 2 to 2, 3, 4, 5, and there are total 8 outputs till here. By default, it is in this mode. And if you want to change the mode, then you have to solder these two pins. Then it will come into 16-bit mode. Oh, sorry, in 16 button mode. Then you have to use the I2C, SCL, and SDO pins. So by default, it is in the 8 mode, 8 output modes, 8 button mode. So we will use this. We will not go for the 16-1 mode. So let's get started. So guys, the leftmost pin, if you hold it like this, is the VCC pin. Here you will give the 5 volt. Next one is the ground. Then we have SCL for the I2C. Then the SDO pin for the I2C. Then we have output 1, output 2, output 3, 4, 5, 6, 7, and 8. So guys, in this tutorial, I am only going to use the first 3 buttons. One button will turn on the LED, second button will turn on another LED, and third button will turn off both the LEDs. So that's what we are going to do. First button one LED, second button the other LED, and third button you can use turn off both the LEDs at the same time. So let's get started. So for the VCC pin, I will connect it to the VCC pin of the PIC like this. For the ground, I connect it to the ground pin of the PIC like this. Now guys, we will leave the SCL and SDO mode because we are using this in the 8-button mode. So now out pin 1 for the output pins, you can use any available digital input output pin of your PIC. I am going to use the pin number D1 for the output 1 and pin number D2 for the output 2 and pin number D3 for the output 3. So we are only going to use the 3 buttons 1, 2 and 3 like this. We will leave the rest because with button 1, one LED will turn on. Button 2, the other LED will turn on, and with button 3, both the LEDs will turn off. So for that, we will also need the 2 LEDs as well like this. Now guys, as you can see, each LED has 2 pins, one longer and one shorter. I label them like this. The longer pin is the power, the shorter one is the ground. You common the shorter pins and then you send them to the common ground of the PIC. Now for the longer pin, you are going to need a 220 ohm resistor like this. This is a safety resistor. It can vary from 100 to like 330 ohm. So you can use any value up to 500 ohms. The higher the value, the dimmer the LED will go. Now guys, for the power pin, connect the power pin of the lower LED to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can send it to any available digital input output pin. I am going to use a pin number B5, that is pin number 38 of the PIC like this. Now guys, for the power pin of the top LED connected to the one end of the 220 ohm resistor, and now again you can use any available digital input output pin. I am going to use the pin number B6 like this. In this way our connections are completed. Now when the one button will be pressed, one LED will turn on, and when the second button will press, the second LED will turn on, and when the third button is pressed, both will turn off. That's how I am going to demonstrate the working of this keypad to you. So let's get to the micro C4 PIC programming. Before that, let me introduce you to the hardware. So guys, this is the hardware. As you can see, these are the two LEDs I am going to use. Out of these LEDs, only two will be used. So one here and one here. And this is the module we have here. As you can see, this is our 4x4 capacitive type keypad module. You can see that here there is no soldering on these two pins here. If they were soldered, it means that it is in the 16 button mode, but right now it is in the 8 button mode. We only gonna use a 1, 2 and 3 to turn the LEDs on and off. So let's get to our programming. So guys, let me zoom in so you can see better. So guys, this is our micro C4 PIC programming software. As you can see that I'm going to use a version 7.2.0. Latest version 7.5.0 is also available. Always go for the latest version, latest is better. So click on new project. This window will pop up, new project wizard. Click on next, write the name of the project. I write keypad tutorial learning microcontrollers. And PIC16F877A is the microcontroller I am going to use. And 20 MHz is the crystal I am going to use. So click on next, finish. Now guys, before you do anything, first of all, press Ctrl S to save your work like this. Now guys, let's first of all declare the LED pins as output. Trace B dot F. We have two LEDs. One at, let me check. Okay, so we have two LEDs. One is at the B6 and other is at the B5. So first of all, we declare the B5 one. Trace B dot F5 equals to 0. So the LED at pin number B5 is now an output pin. So that pin has been declared as output because for the LED we need the output. In case of Arduino, you write it like pin mode output. So in case of PIC, it's a trace register. Now let's give it the initial state. Initially the LED must be off. For that, port B.F5 equals to 0. So 0 means it's low. Like in case of Arduino, it is like digital write low. So here you use this. Give some initialization delay. This is not important, but I prefer you give it in the one-time loop. Now guys, for the second LED at B6, just change this B5 to B6, rest is same. Now guys, for the three buttons that we have on the capacitive touch, just declare them out, declare them like you declare a normal button. So I write trace D dot F1 equals to 1. Now see the difference. For the LED, it was an output 0. Now 1 means it's an input. So trace, right, make it correct. Trace D dot F1 equals to 1. Now this is our first button, that is a B1, button 1 on the touchpad. Oh sorry, capacitive keypad. Now give it the initial state. For that, write down port D dot F1 equals to 0. Why 0? Because whenever this button is pressed, a 1 will be sent. So initially it must be at 0, so we can check the difference. Now we give some initialization delay. Now do the same for the other two buttons. Just copy this for the second button, for the third button, just make it 2. And the second button is a pin number trace D.F2. Now this is D.F2, D2, T2. So we have our three buttons initialized. We have our LEDs initialized. Now we can go for the forever loop. Write down while 1, forever loop starts here, ends here. Now inside this starting and ending, you will write the code. First of all, we write if this button is pressed. For that, we take the initial state. Write down if port D.F1, that is the button at 1 is 1, that it is pressed, or 1 is received, then what should happen? Then what should happen is that the LED which is off at B5 will turn on like this. Now it will become 1. Now else if, just copy this, paste it here, add an else before it. Else if port D dot F1, now F2 is pressed, now the second button is pressed, then the other LED at B6 will turn on. Now again just copy paste it. Else if the third button is pressed, that is at pin number D3, then both the LEDs must turn off. So go for the initial state of both the buttons. Port B dot F5 equals to 0 and port B dot F6 equals to 0. Both will become 0. Now this is our simple code. Let's build the code. The code is built successfully. Let me write it down using the PIC16F877A programmer software. Click on import hex file. This is the file we just created. I click on write. Let me zoom out. Okay, the new code is being written. Let it write. Okay, this is the hardware. Okay, let me power the circuit up using the PIC16F877A programmer tool. I click on. Okay, the circuit is powered up. You can see that no LED is on by default. Now what I do is that I press the 1 key. See, the first LED turned on. I press the 2 key. Second LED turned on. Now I press the 3 key. Both turned off. So that is what we wanted from our programming to do. Now again I press the first LED. It turned on. I press the third LED, turns off. I press the second button. The second LED turns on at B6. I press 3, it turns off. Now again I press the 2. Second LED turns on. Now the first LED turns on. I press 3. Both turn off. Now I press 1. Again 3. See, it turned off. 1, 2. And then I press 3. It turns off. So guys, it's simple as that. So that's how you are going to use the keypad with the PIC16F877A microcontroller. It's a very useful module for your many projects. I will also make more videos on it, how to send a digit to the 7-segment LM016 LCD as well. For now, you should know that how to use it in your projects. This tutorial is good enough to start with. So guys, I hope you learned something from this video. Thank you very much for your time. And if you have any questions, you can ask them in the comment. I will share with you the micro C for PIC programming in the description of this video. So still, if you have any questions, you can ask them in the comments. So thank you very much guys for your patience, and have